Hello everybody, today we're going to be doing LeetCode number 11, container with most water. Let's start by introducing the problem. Given n non-negative integers, a1, a2 to a to the n, where each represents a point at coordinate I, a to the I, n vertical lines are drawn such that two endpoints of line I is at I, ai and Okay, screw the introduction to this problem. I don't know about you, but I find that to be extremely confusing. This problem is not that difficult. I'm going to introduce the problem myself. So let's take a look at the input. The input is going to be an array of numbers. And at each index, the number represents the height of a wall. So if you look at the first index here, the first number is 1, which corresponds to this first wall here of height 1. The second index, index 1, is 8, which corresponds to this red line here of height 8. So what are we trying to do here? We're trying to return the container with the most water. So a container has two walls, which are the height, and the height of the container is the minimum value of the two walls. So here, this container with the red walls here, one of the walls' height is 8, the other wall is height 7. So the height of the container is 7, and the width of the container is just the distance between the two walls. So the distance for this container with the red walls, the first wall is at index 1, the second wall is at index 8, so the distance is 7, so the width of that container is 7. So what you want to do is you want to look at all the container, or you want to return the container that holds the most amount of water. So if you're ready to solve this problem with me, come to the whiteboard, but as always, I encourage you to solve the problem first and then come check out the video. So if you're ready to solve the problem, let's go to the whiteboard. To solve this problem, we're going to use something called ratcheting. So what ratcheting is we have a pointer here at the first index, we have a pointer here at the end index. And at every stage, we are either going to decrement the ending pointer or we're going to increment the starting pointer. So we're also going to be keeping track of the height of the current container, the width of the current container, as well as the area of the current container. At the end of the algorithm, we'll just return the maximum area that we have seen. So what are the conditions where we will either increment the starting pointer or increment the ending pointer? Well, what we're going to look at is the height of the two walls that the pointers are pointing at. We always want to keep the higher height of the two walls because that's going to give us our largest possible area. So at every iteration, we will first measure the size of the container. Then we will either increment the starting pointer or increment the ending or decrement the ending pointer depending on which wall we want to keep. So let's go ahead and go through running this algorithm, and I think you'll understand how it works. So first, we're starting at index 0 and index 8. At index 0, we have a wall height of 1, and at index 8, we have a wall height of 7. So that gives us a container height of 1 and a width of 8, which gives us an area of 8. So because our starting pointer is shorter than our ending pointer, we will increment the starting pointer. So now our starting pointer is a wall size of 8 and our ending pointer is a wall size of 7. So that gives us a height of 7. And now our width is 7, which gives us an area of 49. So we will now decrement the ending pointer because our wall height is shorter on our ending pointer. So now we can see that our our container height is 3. And the width of that container is 6, giving us a total area of 18. Now, because our ending pointer is shorter than our starting pointer, we will decrement the ending pointer. So now both of our walls are of height 8, giving us, and the current width is 5, giving us an area of 40. So what I want to talk about now is we have two walls that are the same height, right? So how do we know which one to decrement? Well, What I'm going to tell you is it actually doesn't matter which one we pick. And the reason why it doesn't matter which one we pick is the only way that we can have a container size between these 2 points that is greater than the container size of these 2 walls is to have 2 walls between these walls that are higher. So to illustrate that, I'll just show you. What if we had 2 walls here that were both of height 100? Well, if we decided to first increment the starting pointer, and then we decided to decrement, then we would hit a wall of 100, and then we would have to start decrementing the ending pointer, right? So eventually we would hit this container that had a greater size than the current container we're on. So even though we're not getting all the possible container volumes, it doesn't matter because the only thing we're looking for is the maximum container volume. So we'll choose to just decrement the ending pointer. So now this gives us a height of 4 and a width of 4, giving us a volume of 16. So we will decrement the ending pointer again. This will give us a height of 5 and a width of 3, giving us an area of 15. So we'll decrement the ending pointer again, giving us a height of 2, a width of 2, and an area of 4. Finally, we will decrement the ending pointer again, giving us a height of 6 and a width of 1, giving us an area of 6. So you can see, going through this algorithm, our maximum area is 49. So we would return 49 as our answer. So what's the time complexity of this algorithm? Well, the time complexity of this algorithm is big O of n. And the reason why that is because we are ratcheting from the end to the start until those 2 points meet. And once those 2 points meet, we're done. So we only look at every item one time, which is why this is big O of n. The time, or the space complexity of this algorithm, is constant because we are not using any extra space to solve this algorithm. The only space we're using is the input array. So we use no extra space. Let's go through coding this algorithm. Let's start by defining 3 variables. We'll first need a starting pointer, we'll need an ending pointer, and then we'll also need the area. We can initialize the start to 0. The end can just be equal to the length of the array minus 1 to get the last index, and the area will just start off with as 0. So while the start is less than the end, we'll want to get 2 things. We'll want to get the width of the current container, and we'll also want to get the height of the current container. And we'll also want to update the area. So what's the width? The width is just going to be equal to the end minus the start. The height is going to be the minimum of the index at the start and the array ending index. And to update the area, we just need the maximum of the current area and the width multiplied by the current height. And the last thing we need to do is just make sure that we're properly updating our starting and ending pointers. So if the start is less than the end, then we'll increment the start. Otherwise, we'll decrement the end. And then the last thing we need to do is just return the area. Okay, so now that we've solved the problem, let's take a look at the results. So here are the results of the algorithm that we wrote. There's really not too much to explain here. This is the optimal solution to this problem. In order to solve this problem, we have to find the optimal or the largest container. And to find the largest container, we need to go through and we need to look at every single one of the walls at least one time. So this was a fairly simple problem. Hopefully you were able to get it without too much trouble. And I hope you enjoyed the video, and I hope to see you next time.